In order to create a project in augmented reality, we can use any 3D program. We chose 3ds Max, Rhinoceros, and Grasshopper. The model has to respect some given geometry patterns, mapping, and file export. The cooperating firm gives the necessary documents. We are going to see that it is possible to respect the technical limitations and to reach, however, excellent results. Normally, the final image of a digital 3D model is produced by rendering, by calculating all parameters of geometries, materials, illumination, shadows, and size, without any specific limitation. The use of graphic post-production could be possible in some cases. On the contrary, augmented reality doesn't allow rendering at all, since it is an application which calculates in real time. Before starting modeling, be sure that system unit setup is correctly set, better in meters. If you import from another program, be sure that there's no cloned faces, turned off layers, or hosted objects. If possible, try to optimize faces and to avoid curved surfaces. Here, we can notice the number of vertices and faces before and after. Initially thought as a curved and three-dimensional surface, then optimized as a polygonal surface without thickness. In the archaeological park, the shaped surface is very wide. There are several and complex elements. The simplification plays a key role to get a successful result. It's very important to consider the wideness of the device we use. In fact, the display of an iPhone or a tablet is reduced, and many geometrical details are lost. Details giving plasticity to elements should be excluded, such as the stones of the wall lose their three dimension, with a resulting flat surface with an applied texture. King of the wall is raw, using simple booleans. The sand surfaces, normally moving, are considered flat, in order to avoid several faces. Before modeling, we consider the existing points of view to visualize the augmented reality. North, from the archaeological site entry. East, from the street. South, from the station. West, from the other street. Northwest, from the wall remain. Those are focused on one part of the project, which is more defined than the other part, the western one, which is only sketchy and remains in the setting. As we can notice from this view, there is a feeling of total completeness. This expedient considerably reduces the working time, as the total number of the faces and of the textures is optimized, with the resulting file which is not heavy. It's important to establish the points of view in order to understand what will be visible and what won't. The hidden faces will have to be deleted, in particular those ones which are hidden by the visible geometry. Way, the result will be a light and easy-to-use model which won't weigh on the total weight of the application. We have to pay more attention on maps. A simplified modeling needs a specific treatment of maps. We particularly focus on the wall, whose virtual image respects the original one, thanks to the textures which are derived from photographs of a part of the existing wall. Photographs have been distorted, cut, scaled, and adapted to the profile of the wall using Photoshop. In this way, a unique big map has been created, not showing annoying repetitions of the model of the texture. Once finished the mapping work, we add other effects, like invasive vegetation, the shades of the remains, rising water, and shadows. Since there aren't the lights of rendering, these will have to be included into maps and manually elaborated, thinking about an hypothetical direction of the sun. A map should fit into a quadrant whose sides are proportional to the power of 2, such as 16 for 16, 32 for 32, and so on. So, we can now rescale the image. We suggest not to overcome 2048 pixels for every side. We will obtain a low-quality image, but not heavy and, however, adapted to augmented reality and to smartphone screens. We import the mapping to 3ds Max and we adapt it to the wall. Since there is no light in the scene, except for the taken shadows, we should consider the proper shadows. So, with the hypothetical light coming from the east, we are making the faces directed northwards and westwards darker. We create a model of map of the darkest wall. 32 for 32 pixels is enough. We save it in JPEG and import it to 3ds Max. Then, we decide the material and adopt the model with any map modifier. Augmented reality doesn't support transparency, bump, and any other kind of effect. Be sure that you are dealing with a default render in order to avoid the use of materials of other renderers which are not supported by the application. Basic colors and bitmap are the only ways we can use to modify the chromatic aspect of meshes. The application is not able to capture the parameters of the materials set with any renderer. It can simply read maps and colors of meshes, which are saved together with geometry in the catalog of OBJ file. Limit the number of imported materials. They make the file much heavier. Export the model in OBJ. Be sure that the faces are triangular and the library of materials is working. Here, we will calculate triangulations. Company Innovastia gave us the program to convert the OBJ file in layer. It is a very easy and intuitive program. We import the OBJ file. Here, we have all the parameters of the model and also its preview. In the Materials section, we can find the texture and colors of the model. Considering the faces which are exposed to light, the parameter related to diffuse light of the applied map will be modified, changing its chromatic value from gray to white. In placement, we can insert Yenikapi, the location of the project. At the end, we can save the file into 3DL format in order to send it to create the application. Thank you for watching.